Hello everyone, let's solve this problem that is based on Schrodinger equation. For 1s orbital of hydrogen atom, radial wave function is given as this one, where A0 is Bohr radius, right? And R is the radius. The ratio of radial probability density of finding electron at R equal to A0 to the radial probability density of finding electron at the nucleus is given as this. So this is the ratio of radial probability distribution at R equal to A0, that is the Bohr radius, and at the nucleus. Calculate the value of x and y. So this is very simple. If this wave function is given, this R of R can be written as psi of R. Then finding radial probability density is very simple. We have to just square this. So we have to figure out just the value of R square of R or psi square R. Okay. So let's start the solution. First of all, I will write the radial wave function of hydrogen atom, that is R of R or psi of R, and that is equal to this expression. Okay. So this is here. Now, where A0 is Bohr radius and R is the distance from the nucleus. Now, let's figure out the radial probability distribution function. So this will be psi square of R, and you have to square this. So if you square it, you will be getting 1 upon root pi square will be 1 upon pi, and this will be giving you this, and this will be to the power minus 2r by A0. Now we'll figure out the value of radial probability density at R equal to A0. So I will just substitute R equal to A0 in this expression. So here psi of R at R equal to A0 will be equal to this much. So I have substituted the value of R as A0. Now I will be getting this expression. Similarly, we will find psi of R at R equal to 0, because that is nucleus. Okay, so nucleus, that is distance is 0, because we take R from the nucleus itself. So if the nucleus is the starting point, R will be 0, and we'll put the value of R equal to 0 in this expression. Okay, so this expression will become 1, and this will be only left. So we'll be getting this. After that, I will just figure out the ratio of these two radial probability density. So this two expression will cancel out, only e to the power minus 2 will come. Okay, and then we compare this e to the power minus 2 with this expression that is given in the question, x into e to the power minus y. Okay, so if you compare it, let me write in this form. E to the power minus 2 can be written as 1 into e to the power minus 2. So x will be 1 and y will be 2. So the value of x plus y will be 3. So that's the final answer. Thank you.